Hello everyone, and welcome to another session. In this session, we're going to continue what we did last time. We're going to be looking at three variable problems, just because this is very close to the end of our session, the end of our class. And when you take the continuation of this class, managerial decision making, a lot of the manual problem solving is very quickly passed over. Instead, what we focus on is complicated questions that involve multiple variables and multiple constraints. It's something that we focus on quite steadily, and so to do that, we need a strong base in the rules governing problem solving of this nature. So, without further ado, let's look at the homework question from last time. Tracy McCoy has committed to the local PTA to make some items for a bake sale on Saturday. She's decided to make some combination of chocolate cakes, loaves of white bread, custard pies, and sugar cookies. Thursday evening, she goes to the store and purchases 20 pounds of flour, 10 pounds of sugar, and 3 dozen eggs. These are the main ingredients in all 3 baked goods she plans to make. The following table shows how much of each of the main ingredient, she requires for each baked good. The table then presents us with the information, and there, that's not 3, it should be there. There are 18.5 cups in a 5-pound bag of flour, and 12 cups in a 5-pound bag of sugar. Tracy plans to get up and start baking Friday. She has 8 hours to bake. She knows that the cakes will sell for $12, the bread for $8, a custard pie for $10, and cookies for $6. How much should she make of each to make as much money as possible? So we see here that the first thing we're going to have to do after we find our objective function is convert all of this information to the same units of measurement. That's where this question is a little more challenging because it requires you to convert everything to the same unit of measurement. So let's look. First, our objective function is very easy. We can find it all in the last 2 sentences. We know we want to make as much money as possible. So max z equals 12x1 plus 8x2 plus 10x3 plus 6x4. We have not 3, but 4 decision variables. Then we have to look at our constraints. So it says in the bottom section, there are 18.5 cups in a 5-pound bag of flour. And we know she has 20 pounds of flour. So 18.5 times 4 is 74. So we have, and all of our flour is given in the first column of this table. So we have 2.5x1 plus 9x2 plus 1.3x3 plus 2.5x4 is less than or equal to 74. That's our flour. We do the same for sugar. We know we have 12 cups in a 5-pound bag of sugar. We have 10 pounds, so that's 24 cups. So again, in the second column of the table, our sugar ingredients are given. We have 2x1 plus 0.25x2 plus 1x3 plus 1x4 is less than or equal to 24. Eggs, we have 3 dozen. So that's 36 eggs, and that's given in column number 4. 2x1 plus 0x2 plus 5x3 plus 2x4 less than or equal to 36. And finally, baking time, we have 8 hours, but our baking time is given in minutes, so we have to convert 8 hours into minutes, which is 8 times 60, 480. 45x1 plus 35x2 plus 50x3 plus 16x4 is less than or equal to 480. So once we have all of that information collected here, it's a very straightforward problem once we reach this stage. There's nothing too challenging about this, as we'll see. So let's go to QM first. We click on Module, Linear Programming, because we're still on base linear programming problems. When we get into managerial decision making, we'll look at some other problems, but we still need to build the base. So let's open a new file, and we'll call it the baking example. How many constraints? In this situation, we have 4. We also have 4 variables. As long as we set this up properly, our table will look very similar to what we've seen in the past. So very quickly, I'll just expand this a little bit. And what I'm going to do is I'm going to open this at the same time because it's difficult to remember. We have a lot more information now. Just let me arrange my form here. Okay. So our first one is cakes, bread. Oh, what were our other two? Custard pies and sugar cookies. So we want to maximize if cakes are 12, 8, 10, and 6. So our first constraint we know from our problem is flour. Flour available. Our second constraint, sugar available. Our third constraint, eggs available. And our fourth constraint, time available. So now all we do is we enter the information from our problem formulation, 2.5, 9, 1.3, 2.5. We do the same for sugar, 2, 0.25, 1, 1. We do the same for eggs, 2, 0, 5, and 2. Then finally for time, one more time, 45, 35, 50, 16, oh, not 26. And finally, we have to enter in the right-hand side here. So our first one, we have 74 cups of flour available. We have 24 cups of sugar. Oh, not 25, 24. We have 36 eggs available. And finally, 480 minutes available. So if our information's been entered correctly, we took a relatively straightforward problem, so it's quite simple to solve. The only real challenging aspect of this problem was ensuring that we had everything in the same units of measurement. So let's hit solve. And we see that we're preparing not 4, but 3 products. Custard pies aren't worth preparing. We're going to make 2.73 cakes, 3.22 bread, 15.27 sugar cookies, and that will generate for us a profit of $150.17. That is this problem solved in its entirety. So again, we're seeing that it doesn't really matter how complex the problem is. As soon as we put it in the correct format, it becomes relatively easy to solve. So let's do another one. Oh, let's go to Excel and solve there. Okay, so let's begin with our baking example. I'll lengthen my columns. And again, for this one, because we have a lot more complicated information, I'll miniaturize this as well so I can see my problem formulation. So the first thing we have is our list of products: cakes, bread, pie, cookies. Now these represent our decision variables. In this situation we have 4. Traditionally we've had 2, but we can enter as many as we would like here. And then our profit per item, cakes is 12, and we get this in our objective function, 10 and 6. Next, we're going to come down, and this is our requirements, where we list our constraints. The first one, flour available, sugar available, eggs available, and finally, time available. Usage will be computed here, and the amount available over here. So we'll do amount available first because it's quite straightforward. 74, 24, 36. Oh, whoops. I had to skip a space. So 74, 24, 36, and 480. If I had not skipped that space, assuming I aligned everything properly in Solver, we would have had no problems. But for simplicity's sake, I wanted to skip it just to make it a little more clear. So this is less than or equal to, and we have all of this in our problem formulation. Less than or equal to, less than or equal to, less than or equal to. Very straightforward, as I said. So 2.5, 9, 1.3, 2.5. 2, 0.25, 1, 1. 2, 0, 5, 2, and finally 45, 35, 50, and 16. The only thing we have to do now is relist our products down here. Oh. Relist our products here. And in this situation, cakes, bread, pie, and cookies. Very simply, now we can add our formulas in, but first we'll mention our key is profit. Profit is the amount of cakes, or the price per cake, times the number of cakes, plus the amount per bread, times the number of bread, plus the amount per pie, times the number of pie, plus the amount of cookies, times the number of cookies. We hit enter, and that gives us our profit formula. We have 4 more formulas to do. Oh, the first one is the amount of flour per cake times the number of cakes, plus the amount of flour per bread times the number of bread, plus the amount of flour per pie times the number of pies. Oh, 1 second, I'll have to do that again. And finally, plus the amount per cookie times the number of cookies. And we're going to go down and do the same thing again. again. And finally, one final time. And once we've completed all this, we've entered our, we've entered all our formulas correctly, then all we have to do in this straightforward problem is go into Data, click on our solver, enter our key information. So the first one is B18. We're trying to maximize our changing our variable cells. This time is 4, not 2. So we highlight all 4 cells. We make it simplex LP, and we add our 4 variables. Less than or equal to. So once we have all of our relevant information completed, we hit Solve. Solver found a solution. All constraints and optimality conditions are satisfied. And we see that we have found exactly the same answer now. We should prepare 2.73 cakes, 3.22 bread, 15.27 cookies, which will generate a profit for us of $150.17. So I'll save this file. Close this, and we'll move on to another problem. So this is our second problem today. The Wisham family lives on a farm in South Georgia where it produces pecans. It has 5 acres of trees that yield approximately 1,000 pounds of shelled pecans per year. The family uses all of its harvest yearly to produce pecan pies, pecan cookies, 1-pound bags of shelled pecans, and 5-pound bags of shelled pecans. The family sells pies for $5, cookies for $3, 1-pound bags for $7, and 5-pound bags for $16. It requires 4 ounces of pecans to make a pie, 6 ounces of shelled pecans to make cookies. It takes 55 minutes to make a pie and 15 minutes to make a batch of cookies. There are 120 minutes of baking time available. So we see already that we do not have two decision variables in one of our constraints because they do not have to be baked. It takes 6 minutes to package a pie, 4 minutes to package cookies, 10 minutes for a 1-pound bag, and 12 minutes for a 5-pound bag. There are 300 available minutes available for bagging. The family wants to know how many of each they should produce to maximize profit. So, very simply, we have to first determine our objective function, which is given to us right in the middle. Max z equals 5x1 pies plus 3x2 cookies plus 7x3 1-pound bags plus 16x4 5-pound bags. Then we have to look at our constraints. The first one, 100 pounds of shelled pecans. To do this, what we have to do is we have to convert to ounces because some of our measurements are given in ounces and some are given in pounds. So we're going to convert to ounces. There are 16 ounces in a pound. So we don't have 1,000 pounds of shelled pecans per year. We have 16,000 ounces of shelled pecans. So x1 plus x2 plus x3 plus x4 is less than or equal to 16,000. Next, our ingredients. 4x1 pies plus 6x2 cookies plus 16x3, which is 1 pound bags, plus 80x4 5-pound bags is less than or equal to 16,000. There are 120 minutes of baking time available, so 55x1 plus 15x2 is less than or equal to 120. x3 and x4 don't get baked. We have 6x1 for packaging plus 4x2 plus 10x3 plus 12x4 is less than or equal to 300. Everything collected together will look like this. So we have 4 decision variables and 3 constraints governing our operation. So one more time, let's go into QM. We're going to launch a new window, and we'll call it the pecan example. Number of constraints, we have 3. Number of variables, 4. And we're trying to maximize our profit. Pies, cookies, 1 pound bags, 5 pound bags. And we know from our problem formulation that we have 5, 3, 7, 5, 3, 7, 16. Constraint number 1 we know is pecans available. Constraint number 2 is baking time. And constraint number 3, packaging time. Very simply, on the right-hand side, 16,000, 120, 300. 4, 6, 16, 80, which is pecans we use. Baking time, we have only 55 and 15. There is no baking necessary for 1 pound or 5 pound bags. And packaging time, 6, 4, 10, 12. So this is a complete problem. It was relatively easy. We took what looked to be a complex problem here, and very simply, once we align it in the correct problem formulation, it's very easy to put into QM. We hit solve, and we see, very simply, we should not produce anything but 5 pound bags. The reason, most likely, is because they generate the most income and they require the least amount of resources per item. So very simply, we want to produce 5 pound bags. If we do that, we'll generate a profit of $400 by producing 25 5 pound bags. All right, everyone. What I'm going to do now is we're not going to solve in Microsoft Excel because we've done it so many times. I will come back to that in the future, but for today I want to leave you with extra time to solve your problem because it is a little more complex and it is necessary to complete the attendance quiz. So I will address the class at the 40-minute mark again. Thank you everyone for listening. As always, if you do have questions, please let me know through Kakao and I'll do my best to help you. So without further ado, I'm going to put this on the screen. Again, if you have problems, feel free to contact me. All right, everyone. Hopefully everything was very clear. And if you have any questions, as always, please contact me. I'll see you in the next session. Goodbye.